Hi, everybody. How are we today? Enjoying the conference? Good. I love the NDC conferences. I've been doing them for years now. They're my favorite conference, and I'm not just saying that because I'm here. So this talk is all about the new features of the JavaScript language. I was very excited 2 years ago when I found out that there was a new specification coming for the JavaScript language. And looking at that specification, I could see that this was a huge step forward for the JavaScript language. I mean, it had been years since anything significant, really meaty, had been added to the JavaScript language. And I was very excited to start working with these new features even before the specification was final. And that was possible because back then, when it was still called ECMAScript 6, there were transpilers available so I could start writing this code into projects and not really worry about it screwing up in production because the transpilers would just put it into ES5 code and I knew everything would work in the browser, so that was all great. But it's been 2 years now of working with some of these new features, and I've discovered that just like ancient cartographers when they were drawing out maps of the world, there are some of those areas that just haven't been fully explored. Areas where ships just kind of disappear, we don't know why. So they used to draw dragons and other mythological beasts on the map just to represent those areas where you need to be a little bit cautious if you're venturing into that area. So my goal in this presentation is maybe you've looked at some of these features or are using some of these features, maybe not, but over the last 2 years I've picked up on areas where developers run into problems and where things don't work like you would expect them to work, and we'll start, as an example, with arrow functions. How hard could they be? They're actually one of those features of ECMAScript 2015 where I've seen people struggle the most. So I'll also give you a little bit of an overview of what these specifications are, just in case you haven't worked with some of these new languages. But if you're a C# developer, arrow functions are just like lambda expressions in C#, almost identical. The rules are almost the same. For example, this first bit of code here, that represents an executable function, which I think my computer just got very unhappy. Again. Yeah, there we go. Strange patterns on the screen. So I think I might have to reboot real quick. 1 second. I'm going to focus on this for just a second, and as soon as I get back up and running, I will, I'm going to have to completely reboot. That's unfortunate. You know, another laptop might not be a bad idea. I'll just have to get the slides off of OneDrive or something. I'll try it once more here. But while this is rebooting, let me just tell you that arrow functions are almost just like the functions, lambda expressions in C#. That is, if I want to write an arrow function that only takes one parameter, I have to do a hard reset here. I don't need parentheses around that parameter, but if I have an arrow function that takes 2 parameters, I need the parentheses, and all of this would look glorious if it was actually on the screen. Interesting that it did that when I put the pen on the screen to annotate it. We'll try it one more time here. We're almost there. See if we get a display. Yes, okay. See me log in. Let me try to bring this up. Press that button carefully. Let's try the pen real quick. Okay, so far so good. No one breathe. This is defining a piece of executable code that takes one parameter x and it goes to the expression x times x. So just like in C#, if I just want to write a simple expression, that's going to be the return result. I don't need a return statement. I don't need curly braces or anything like that. Add is taking two parameters, x and y, that'll return x plus y. And again, we're defining something that I can execute. So I can say, square the result of adding 3 and 5 and log that out, it would be a 64. Arrow functions are beautiful because JavaScript is a very functional language. There's lots of APIs that are higher order functions. So they're functions that you can pass in other functions to do work. A good example is the map function that's now available on an array. Instead of saying numbers.map function keyword, parentheses, and all that noise that used to be in JavaScript, I can now just say numbers.map, and here's a little lambda expression, n goes to n times 2, so I'll double everything in the array. So arrow functions look good, but it's important to note that arrow functions are not a replacement for the function keyword. There's a couple places where you cannot use arrow functions. It's syntactically illegal, for example, to use arrow functions to define a class member. And then there's other places where arrow functions just don't work like you would expect. So let's talk about a few of those scenarios. And here's one scenario that comes up. Here's a piece of code right here where someone is saying, I want to take these numbers and I want to map them into objects where I would expect to get back 3 objects that would be value colon 1, value colon 2, value colon 3. But what I will actually get back is an array with 3 undefined values in it, because when the JavaScript runtime evaluates this expression with the curly braces, it doesn't see that as me trying to return an object literal. It sees that as me trying to open up a code block to perform some work. And once you start a code block with curly braces, you do need an explicit return statement if I wanted to return value colon n for everything in that array. So what JavaScript sees is some code that it executes and returns undefined. How is that even syntactically legal? It's still syntactically legal because technically JavaScript, we don't use this very often, but it does have labels in the language. You can add a label to a line of code. So what JavaScript is seeing there is a label called value that just points to the expression n, but it doesn't produce the result we want. So don't do that. The easy fix in that particular case, yes, I could use an explicit return statement, and I can also wrap this thing with parentheses. And then the JavaScript runtime will say, oh, OK, what you really want here is an expression that is an object literal, and build an object that has a value property, and I'll stick n inside of there from the array. So then I'd get back value 1, value 2, value 3. Making sense? Interesting? Hopefully this is what you came to see. Good. The other special characteristic about arrow functions that you probably know if you've worked with this feature is how they preserve the lexical this reference. So here's an example of an object that will not work correctly, because when I say numbers.forEach, here's a function, please add n to sum, what is the this reference? Well, it's not going to be pointing to this adder object that I'm inside of, because the this reference, we know in JavaScript, it's dynamic, it's slippery, it's set up by the call context. So when forEach calls my function, forEach isn't going to call my function and pass in n and set up the this reference for me appropriately. So this is probably referencing the window object, and I'm going to be getting an error, cannot read properties sum, if I try to execute that code. One of the things they did with arrow functions, which is kind of borrowed from CoffeeScript fat arrows, is that when you define an arrow function, it's going to preserve the lexical value of the this reference. In other words, since this arrow function is defined inside of a function that is inside of this object, and assuming add gets invoked correctly, this arrow function is always, always, always going to be using a this reference that is exactly the same as the this reference that would be outside of the arrow function inside this function. So am I making sense? No? What's wrong? Just that expression? OK. Yes, yes, yes. A little jet lag, so I'm a little leery about what I might be doing wrong here on front of the stage. That code will work. So that will actually refer to this.sum, and I will get back a result that is equal to 6, which is what I would expect. That's nice, and it's very useful in a number of scenarios, but it's also, you have to be aware that it can be dangerous in a couple scenarios. I'll explain why in just a minute. But before I get there, this code works. just so we're clear, that's an arrow function that's being defined inside of a function. So it'll capture that this reference. And the specification talks about the this reference becoming static. It's no longer dynamically determined. It's sort of pre-bound into that arrow function, and no one can change it. But what about this bit of code, where I have this object member defined as an arrow function and an arrow function inside of there? It's not immediately obvious when you write that code. You might say, well, I have an arrow function here, and it's inside my object, but the scope for that will be taken from the scope from this arrow function, and the scope of this for this arrow, the scope of this for that line of code. It's not inside of a function. So it's whatever this is right here, where that's being lexically defined. So I could very easily be ending up with a this reference that is still pointing to the window object, or whatever this was inside of, whatever that object was inside of. Does that make some sense? So too many arrow functions there. And then the other thing to keep in mind about arrow functions is that you cannot bind, apply, or call to change the this reference any longer. So any other normal function in JavaScript that's declared with the function keyword, I can get a reference to that function, and I can say function.bind, here's your this reference to use, or function.apply. I'm going to invoke this function and pass in your this reference. But with arrow functions, it does not work. Once the this pointer has been captured by the arrow function, there's nothing you can do to change it. So in this example, I have my object adder, and now I'm trying to define an arrow function that I'm going to bind onto that adder. So I'm trying to say, here's what you'll use as a this reference, but it's not going to work. React programmers run into this a lot because they try to define functions and bind them to the object that they're going to be working with. And when they define them using arrow functions, they can run into trouble. What are some other scenarios where you run into trouble with that? Well, let me start with this second example, actually. If you're using jQuery, it's quite common to wire up like a button click event. And then when jQuery invokes your callback function, because it's been clicked, jQuery will try to set up the this reference so it can pass it in as the DOM element that was clicked on. Unfortunately, jQuery won't be able to do that any longer if you define the callback as an arrow function. Because again, you can't use function.bind or call or apply to manipulate the this reference anymore. So this piece of code, the this reference, will not be the one that jQuery tried to set up for you. It will be whatever it captured inside of whatever scope we're in. So instead of setting name on the DOM element, chances are you're setting the name of the window or the name of the module or something like that. The place where I first ran into this and discovered it, much to my dismay, was inside of Jasmine unit tests. I thought, well, this is really nice. I'll just start defining my unit tests as arrow functions. But if you've ever used Jasmine, you can set up a test context in Jasmine and attach things to a this reference inside of like before each calls, just to keep track of things and have them available inside of the its throughout all of your tests. And then Jasmine, when it invokes this function, to execute the unit test, it tries to set up the this pointer so you can get to the test context. But if it's an arrow function, you don't get the test context. So I had tests failing and trying to figure out why, and I thought maybe it was a bug in the transpiler. And that's when I actually dug into the JavaScript specification and saw, oh, this is actually how arrow functions work. And I also found out then when I looked in the specification, arrow functions have a couple other idiosyncrasies, let's call them, because they're not normal functions. They don't have their own implicit arguments variable. Whatever the arguments are there will be whatever the arguments were for maybe the function I'm inside of. So if I try to add 3 and 5, even though I'm passing in 2 things, this implicit arguments variable here would return 0, because maybe I'm inside of a function that had 0 arguments. Is that making some sense? So don't rely on some of those typical function behaviors and implicit variables that you would get when you're using arrow functions. Let's talk about template literals for a second. Template literals are that new feature in ECMAScript 2015 where I can use the backtick, so not a single quote, not a double quote, but a backtick. And then the JavaScript runtime will evaluate the $ curly brace expressions that are inside of the string. And if I had X and Y defined before I reached that exact line of code, JavaScript would produce something like 3 + 5 = 8. Because it would actually evaluate all this stuff. But a lot of people, when they hear the word templates, they think naturally that, oh, okay, I can define a template like this and then reuse it with different objects. So I'd be able to define a template and then later on give it some X or Y and tell it to format itself, but that's not how it works. It's literally just in line there. When you define the template, any of the variables that you are using inside of that template, they have to be available in the scope. And the JavaScript runtime, if it doesn't find X or Y, it'll say something is not defined. And then people say, well, why are they templates then? Why don't we just call this string interpolation? Well, the original specifications for this actually called them quasi-literals, so they're kind of fake literals. They're not really literals, but it's JavaScript, so it has to be a little bit quirky, right? You can make them reusable, though. So here I'm just going to define template now as a function that takes two parameters, x and y, and it returns the template literal, x plus y equals x plus y. And so now all I have to do is invoke that function and pass in my model data. So invoke template, pass in 2 and 2, and I get back the string 2 plus 2 equals 4. And if you want to get a little bit fancier, you can use a feature in ECMAScript 2015 known as destructuring. So this syntax right here, I don't have a slide on destructuring, I don't think. Curly brackets on the left-hand side of an assignment statement or in the list of parameters to a function, they destructure an object. So this is creating two variables, x and y, and what it will do is pull the x property and the y property out of an object that I pass in. And so now I have the ability to invoke this template and sort of pass in a model object, right? I pass in an object that has some properties, and there's a template literal in there that'll spit it out. So now it feels a little more templatey. Feels a little more like handlebars or something like that. So speaking of destructuring, some people don't like the crazy syntax that you can now do with ECMAScript 2015 and plus some other features in the future. And actually, I do have here something on destructuring. So what is destructuring? Destructuring strikes some people as funny, but square brackets on the right-hand side of an assignment, that's constructing something. So I'm constructing an array using an array literal. Square brackets on the left-hand side of an assignment is destructuring. So it's creating new variables, x and y, and then it's trying to pull, in this case, element sub 0 and element sub 1 out of whatever's on the right-hand side. So I would get out of this bit of code, x is 22 and y is 44. Very good. That one's a simple example. But you can get a little bit weirder. So here's an example where I have an object and so there's array destructuring and there's object destructuring. Object destructuring, well, object literals are when you have curly brackets on the right-hand side of an expression. Object destructuring is when you have the curly brackets on the left-hand side of an assignment. So this is actually creating two new variables, state and country. State is going to have a default value of New York, but it's also going to try to read the state property out of address. Since there is a state here of Maryland, that's where I live in the United States, the result of this would be the state would be pointing to a string Maryland. Country, however, since there's no country in my address object, it would get that default value of USA. So that's where people start to feel a little bit uncomfortable with destructuring. Why don't we just write the code a little more explicitly? But then you can also do really crazy stuff with it. So here's an object literal defining an employee with a first name. It's a complex object because I have an address inside of there, state, Maryland, country, USA, and my favorite numbers. Not really, but whatever. This is a destructuring assignment down here because the curly braces are on the left-hand side. I'm trying to pull out the first name property. Fine, that'll be equal to a Scott. This is defining a state variable. It's going to drill into the address of the employee and pull out the state of Maryland. And this little quirky expression here is saying go into favorite numbers, skip the first element of the array, pull out the second one. That would be a 55. So now I have three new variables, first name, state, and second. And they would be equal to Scott, Maryland, and 55. That's a little bit odd until you're used to it. But it gets better or weirder, depending on how you think about it. What's this produce? Yeah, it's a variable length, and since a string has a length property, we'll be getting the length of that string out of it, which is, looks to be 4, right? WT question mark, 4 characters. Even more interesting, I'm going to put a couple different operators together. So first of all, you might have heard of the bang bang operator. Bang bang, you're a Boolean. It's a way to do a type coercion in JavaScript. So I want to know if value is true. So first I'll not it to get it into a Boolean, but that's the opposite of what I want. So I'll not it again to get a true out. So let's combine that with some other syntax. So what is this syntax? This is the spread syntax that's part of ECMAScript 2015. Spreading allows me to take an array and then spit out the individual elements of that array into another array. I can also use it when I invoke a function to take an array and spread the array across the parameters to that function. So if I wanted to invoke a function that took 3 parameters, I could invoke it and do ... numbers, and 1 would go to the first parameter, 2 would go to the second parameter, 3 to the third parameter. But in this example, I'm taking numbers and spreading them into an array. So I'll get back an array 1, 2, 3, 4, 5, 6, kind of like flattening. Now, in the next version of ECMAScript, which you can already take advantage of because transpilers like Babel allow you to turn on features that aren't part of an official specification yet, they're still coming in the future. But in a future specification, you can also spread objects. So I want to take this data object, and then I want to build a new object result that'll have some additional data in it, but spread data into it. So result will actually have X and Y properties after that is evaluated. Making sense so far? So now, I can't remember what library this is in. I can't remember if it's in Redux. It seems to me it's something React related. What on earth does this do? Well, what it's trying to do is first determine, the spread operator has a very low priority. First determine if there is data or not, the not data. And if there is data, the result of that will be this piece of the ternary expression, and the ... means we will spread data into this result. And the whole goal of this is that if we don't have data, what I want to spread here is this false condition, which is I just want to spread in default as true into that object. But a lot of people look at this ... bang bang and start to say maybe things have gone too far. I don't know. But that's actually in a GitHub project if you do some searching. What about this const keyword I've been using? Const and let were introduced in ECMAScript 2015, and a lot of people these days are saying use const whenever possible. That should be your default. When you're declaring a variable, use const. And const means no more assignments to that variable, and it makes it easier to reason about. Use let if you have to do an assignment. But const, what it should do is if I define a variable x equals 2, but then I try to reassign it somewhere later in the code, I should get a type error. I'm trying to assign to a constant variable. So in this case, if this is really something I had to do, I should be using let here, or maybe even var. But just so you know, const doesn't mean immutable. So I cannot declare const numbers equals some array literal and expect that to prevent someone from pushing or popping or slicing that array. That works. If that's something I wanted to do, I could use the object.freeze API. That would prevent someone from pushing something in. That would generate a type error, should generate a type error. And let's talk about collections a little bit. So they did do some good new things to prevent crazy errors in JavaScript. If you invoke the array function and you pass in 3 parameters, that will give you back an array that has those parameters as values in the array. But if you invoke the array function and only pass in 1 thing, it assumes you want an array of that size. So it doesn't build an array with a 10 in it. It builds an array with 10 undefineds in it. And that becomes a problem. That's actually something that I've seen people run into when they're doing a little bit of dynamic programming and doing array.call, and they're not sure how many parameters they might have to pass in. Just so you know, if you're ever in that situation, there is now an array.of, which is the API you should be using when you really want to create an array given some parameters. and it takes a var args. It takes a variable number of arguments. So I could pass in 10, 11, 12, and it will build me an array with 10, 11, and 12 in it. And what's interesting about, there's another one, array.from, which is actually kind of odd. What it will do is it will look at this object that you pass in, the first parameter, to see if it's iterable or to see if it has a length property. And if it just has a length property, internally it just sets up a loop from I equals 0 to I is less than length. And in this case, I'm just demonstrating that you can also pass in a callback function that takes the value that it found at that index and the indexing, the key that it used to get in there, like 0, 1, 2, 3, 4, 5. So what this would do is just build actually an array that has the values 0, 1, 2, 3, 4 in it. Fascinating, I hear you say. Tell me more. All right. There's some new data structures in ECMAScript 2015. You should just be aware of how they work. There's a new set. So sets shouldn't have duplicates in them, but it's just doing a reference or a value comparison where if I create a new set and try to add 9 twice, there'll only be 1 9 in there, which makes sense. But if I try to add 2 arrays, that's 2 different objects that the set sees. So it's going to happily accept those 2 different arrays, and the set size will be 2. Makes sense to a lot of people when they see this, I think, right? You just have to be aware that that is the behavior. If I were to try to add the same object reference twice, so the same array I try to add twice, then the set.size would just contain that array, wouldn't add it twice. A lot of people have asked over the last year if there's a literal notation for map or set. Map is another new type that was defined by ECMAScript 2015. We have array literals and this nice syntax to create an array. Is there something similar for map or set? And the answer is no. We have array literals, we have object literals, and that's still just the only literals we have. If I want to create a new map, this is sort of the quirky syntax to create a map. I pass in an array of arrays, where each array inside of here contains the key value, the key, and then the value for it. Classes. This is where things start to get interesting. Again. So typically when people are teaching ECMAScript 2015 or describing these features, they tell you that classes are syntactic sugar for what we've always done. In other words, if I define a class with a constructor and it has some methods like do work and it has a property like get and set name, behind the scenes, all that really is doing is just what we used to do, which is let me define a constructor function and then let me modify the prototype object of that constructor function and add some members to it, because every object that is instantiated from that constructor function will have its magic prototype reference point to that prototype object. Therefore, every object that is instantiated from this constructor function will have a do work method and a name property that has a getter and setter. And for the most part, this is true. For the most part, you can think of classes this way, that when I'm writing a class, it's really just behind the scenes desugared into what I've always been doing, perhaps, if you've ever used this approach to JavaScript programming, if you like the object-oriented style. But there are some important differences between implementing employee using this style and implementing employee using this style. One such difference is in hoisting. So if you're familiar with the term hoisting in JavaScript, you typically associate it with evil powers, right? It's not something that we typically like. But it does allow me to write code like this. I can define a function down here at the bottom of my JavaScript file. But thanks to hoisting, that symbol, employee, is actually available right from the start when I am executing code at the top of this file. Therefore, if I write code that says const equals new employee, that's going to work just fine, even though I have employee defined below. The same is not true for classes. If I tried to define a class at the bottom of the file because it's a utility class and I kind of want to push it out of sight and do some real work at the top, this is not going to work. It's going to throw a reference error. Classes actually do hoist, but they're not legal to use when they hoist. So you should get a reference error for this. And so what do I mean when I say classes hoist, but they're not available to use? There's this wonderful term in the ECMAScript 2015 specification. They talk about this thing called the temporal dead zone, the TDZ. I think is a fantastic name for a movie, the temporal dead zone. But what they're talking about is that there is a period of time where, and here's another example, let. Var variables hoist, right? If I was using var x equals 2, x is available everywhere inside of that function, right? That's what hoisting does. But if I declare that variable x with let, like it is here on the slide, technically x is hoisted. It is available right from the top of the function. But the specification also says that that is a temporal dead zone. Until you reach the line of code where x is actually formally declared with let or const, if anyone tries to access x, the runtime has to throw a reference error. So, yeah, JavaScript. Another difference, if I define employee or human, well, the example here is I'm defining a constructor function human. I'm manipulating the prototype to add a do work method to humans that are instantiated from that constructor function. If I want to do some reflection, that is iterate through a new human and find out what is available inside, the for in loop will give me back do work as an available thing inside of a human. But if I define human, or well, in this case, horse, as a class, and I try to for in through a new horse, that method's not seen. So you cannot reflect as easily over something that has been defined with a class. And that trips people, I've seen that trip people up a bit. What if I really wanted to do that? What if I really wanted to for in over a horse and find out what's inside of it? Well, I can't exactly for in, but what I can do is I can use object.getPrototype of an instance of a horse. And then there's an API object.getOwnPropertyNames on that thing that I get back from getPrototype of. And this is if I want to find the available methods on an object. That would actually tell me, in addition to do work actually, that would tell me about the constructor too. So it's telling me, yes, there's a constructor there and there's a thing called do work there. So slightly different API. This is a for of loop, by the way. How many people know for of? Just a few. So for in has always been in JavaScript, and it iterates over the available keys that are in an object or in an array. For of actually pulls out values. So if I for of over an array, I actually get the values that are inside, whereas for in gives me the indexes, and I have to use them to index into the array. So for of is nice. New is required. So paranoid JavaScript developers of the past, when they wrote constructor functions, quite often they wrote some defensive programming in there that used operators like instance of to make sure that no one was invoking the constructor without using the new keyword. But in ECMAScript 2015, you don't have to do that. If you write a class and someone tries to invoke the constructor for that class, and I don't have one defined here, but it wouldn't matter, even if I had a constructor there, so that's the word constructor with curly braces. I would get a type error if I tried to invoke horse without using the new keyword, so I don't have to do that anymore. But this being JavaScript, what's interesting is I can define a constructor and still return whatever the heck I want. And that works, and that's legal, because it's JavaScript. So I say new horse, and I get back something with the name of Jiffy and no do work method, right? Let's talk about modules. So I have to tell you, when I first looked at the specification and I saw that there was going to be modules in JavaScript, I thought, yes, my prayers have been answered. I've been wanting something like this for 10 years now. You know, every other language I work with, C# and Java in the past, and Python and Ruby and everything, has some ability to encapsulate code and modularize it and spread things across the file system, and I don't have to do weird things in the language just to architecturally hook things up to work. These days, there are times when I look at modules and I think, yes, I am being punished for what I've asked for. That's a quote from Oscar Wilde. Any Oscar Wilde fans out there? He writes some really wonderful prose. English fellow, and he's written plays and books and all sorts of interesting things. I'm sure you've probably seen a movie or something that was inspired by one of his works. So what are modules in ECMAScript 2015? First of all, they're beautiful because when I write code that is targeting ECMAScript 2015, I no longer have to worry about this syntactic noise that litters every .js file out there. No more ifs to control scope. No more use strict, because in ECMAScript 2015, if you're in a module, you are in a strict mode by default. All of that goes away. I can open up a .js file and just start writing code, and I don't have to worry about anything leaking out into the global scope by default. It doesn't happen anymore. Instead, I can start writing things in a file, and I can pick what I explicitly want to export to the outside world for them to consume. So inside of this file, if I write a function work, unless I explicitly export that thing, no one else can see it, no one else can use it, no one else can touch it. And I can either export it by using the export keyword right there, so I could say export function work, and it would be published. Some people like to write all their code and then put their exports down at the bottom so they're easy to find. You just always scroll to the bottom of the file. Oh, that's what I'm exporting. So here I'm exporting two things, exporting work, exporting the person class. You can export functions, you can export classes, you can export variables, you can export just about everything. And ECMAScript 2015 also has a slightly confusing concept of a default export, which I'll talk about here in just a second. But it's basically a way of saying, all right, if someone wants to import from me and they haven't specified exactly what they want to import, they get the person class. That's basically what that syntax is saying. There's also a syntax that allows you to roll things up. And this is quite useful if you're building a library or you want to build an API. It's even quite useful inside of applications sometimes. This is basically saying, hey, take everything from this module, creatures, and export it, and also take everything from the humans modules and export it. And so now I have a module that other people can work with without knowing about these lower level modules, creatures and humans, and referring to them directly. Modules, by the way, if you haven't seen this syntax before, you don't have to specify a file extension, but this is literally saying, in this folder, there should be a creatures.js file, and that's where I want to grab exports from. So you can use paths and relative paths to navigate to the modules that you want. And then there's imports. So when someone has exported something, I can import things. So I can import person and animal from lib. These names have to match the names that are being exported. So if someone exported person, I have to import person. Be very careful if you forget to use the curly braces, because if you don't have the curly braces, you're asking for the default export. And so I've seen a lot of people use the import statement, and this thing is undefined, and they don't know why, because, hey, that module, I see it, exports a human person. But unless it's a default export, do I have enough pen markup on here yet? Unless it's a default export, you don't get anything here. And if they do have a default export, you can name this whatever you want. So they could be exporting foo, and I could be importing bar, and it would work. There's also the ability to just say, I want to import everything, and this becomes kind of like a namespace. So import everything, put it in this lib variable, and now I can say lib.this or lib.person, lib.animal. Fascinating, I hear you say. So some important behaviors to understand about this. First of all, let me back up a second. So when I first looked at this syntax, I thought, oh, this is quite clever. I can imagine this thing exporting some sort of module object, and this over here is doing a destructuring. So what I'm doing is creating a local variable called animal, and it's just sort of destructured out of that module. That is not what's happening at all. The specification refers to these as bindings. It is not destructuring. And here's why that's significant. Let's say I have a module that exports a simple variable counter equals 0. And it also exports a function that I can use to increment that counter and add 1 to it. Some other module imports that counter and tries to manipulate it. That's a syntax error, because these bindings are you can think of them as const. They're immutable. I cannot change counter. And you might say, well, am I getting a copy of that counter? What's really happening here? It's really quite bizarre until you sit down and think through it and look at the specification. You would think a primitive value like a number, you would be getting a copy of it in this other module, but that's actually not what's happening. If I import counter and increment, I can look at counter and it's a 0. Sorry. And if I invoke increment, which is jumping back into this module to increment this counter, I see that change in my other module. You can so don't think of these as simple variables. Think of them as bindings, and they're almost like to C++ developers, a pointer to a pointer. Or, I'm getting a pointer to that other number that's over there. And when I look at counter, I'm referring to that counter really that's in the other module. Yes, sorry. And think of it like a singleton, so they'll all see the same counter. Yep. The question was, if I imported it somewhere else into a second module, does it see that same value for counter? And the answer is yes. You can almost think of this like a singleton, and each module gets a binding to it. And the bindings are live, so a slightly different example. We're going to export an object now with the name of Oscar. And then just some functions to do things like reset to a new object and inspect the name that module knows about. This behaves pretty much like you would probably expect. I can set the creature's name. When I import creature, that's an immutable binding, but creature.name is just a property on that thing, so I can change the name. And if I look in that other module, what name does it see? It sees Winnie, because my module changed it. And if I reset things, that resets my binding. So my creature goes back to being named Oscar, because now we're looking at this object. Making sense? What's the default value of this inside of a module? It's undefined, just so you know. Unlike when you're not inside of a module and this is the window object or something else. So you might be looking at this and saying, well, Scott, why do you feel punished when you're using modules? It's because the ECMAScript 2015 specification was very clear that they wanted a static syntax for modules. And you can get into situations where you start importing a lot of things, or you do a lot of bookkeeping, right? This is actually from a unit test in the Angular 2 framework, where we're trying to write tests using ECMAScript 2015 modules. First, we have to import things from the test framework. Then we have to import some of our infrastructure that helps us test things. Then we have to import the things that we actually want to test. And then we have to import some other helpers down here. So there's, 40-some lines of imports before I even get to the test code. Now, that's an extreme example, but it can sometimes feel tiresome. You just want to use this thing that's in another file. And it used to be so easy in JavaScript, but now I have to manage these imports to actually formally bring it in. And I would expect over time, tooling is going to help us solve this. I know JetBrains WebStorm already has a feature where if you just type that you're using creature, it'll say, oh, do you want me to add an import statement for it, which is kind of nice. And if you come from a Node.js background, or if you've ever used CommonJS or any of these other informal module specifications, community-based specifications that have been out there for modules, you might say, well, can't I do something dynamic? Like, this is the kind of code people might write with Node to say, I want to go out and down here, I want to require a bunch of files that I find. So I just want to write some code to go in a directory, loop through all the files that are found there, and dynamically import them. That doesn't work with ECMAScript 2015. Again, the specification, when they were designing the module syntax for JavaScript, they didn't want dynamic stuff. They wanted modules to be very explicit and very static. and give tools the ability to parse a JavaScript file and analyze the import statements without actually executing JavaScript code. And they felt that that would enable a number of good tooling benefits as well as a number of good runtime optimizations. So modules feel a little bit inflexible sometimes. You don't have any wiggle room. You have to specify specific module names and import specific symbols that you want. The other interesting thing about modules is that the module syntax that we're looking at is complete and written in stone, and it's not going to change. It is officially part of the specification. What the specification does not provide any guidance on, however, is how those statements should actually behave in a browser or an environment like Node.js. They basically say, here's the syntax, now you guys figure out what's going to happen, which means it's impossible to use any of this code without running through a tool that will stitch together modules for you. You know, you have to use a transpiler, you have to use a tool that's going to emit code that will work in the browser and get rid of the import statements. Right now, there's two, and this is another big source of pain for me with modules. Originally, when I started working with modules, I selected this tool called System.js. System.js is a tool that gives you an API like, hey, I want to dynamically import this module. It's going to be the main entry point for my application. And once System.js brings that file in, it might see that that main.js file imports some other things, and it'll just go out and grab everything that you need. It can do it all dynamically, too, just fetch things. The reason I initially wanted to use System.js is because System.js says that, or the whole goal behind System.js is that it's trying to implement the future specification for how module loaders should behave. So someday in the future, or perhaps when our grandchildren are programming, there will be a finished specification for how module loading works, and System.js should reflect exactly what that specification says. My frustrations with System.js are that it is not a finished specification. It still changes, and APIs change. And you can have a perfectly working system one morning, and then do an NPM update and get a new version of System.js, and all hell breaks loose, and nothing works. So I've kind of been off of System.js for about 6 months now. I might revisit it next year when things are better, or closer, perhaps. So one problem with System.js is changing standards. Another problem is performance. Actually, the Aurelia team ran into this. System.js, since it's trying to follow the specifications, it builds on top of specifications like the promise specification. So when you try to import a module, it'll return a promise, and you can wait for that promise to resolve to know, hey, my module has now arrived in the browser. Unfortunately, some browsers, and System.js, I should mention, when it's loading a large application, it's building up hundreds, perhaps thousands of promises to do all this resolution work. And in some browsers, promises don't perform very well. I think it was Internet Explorer that was taking, some version of Internet Explorer would take 6 minutes to load an application, where in Chrome it was 100 milliseconds. And it was all because of the promise implementation in Internet Explorer. They actually had a regression bug that was causing a problem. So it's not a perfect world. I moved away from System.js, and for the last about 6 months, I've been using a tool called WebPack. WebPack is one of a number of tools that understand ECMAScript 2015 modules. It understands CommonJS modules. It understands AMD modules. It understands UMD modules. It knows how to work with TypeScript and Babel and all the transpilers. It's just one of those Swiss Army knife tools that does everything. A lot of people use WebPack and completely replace things like Grunt and Gulp, because you can use WebPack to make an entire build system. And the whole essence of WebPack is that it's a tool that you're going to run at build time, so before things get to the browser. And then you're going to tell it, here's the entry point for my application. Please go to entry.js. WebPack will look at that file, see that it has a couple import statements. It'll say, OK, let me go to those files, and they have import statements. So again, it just goes through the tree of dependencies, puts all the JavaScript files together into a single one, or you can build multiple files too if you want. In this case, we'd be doing a single output into a file called bundle.js, and voila. everything's resolved, and I don't have to worry about a runtime module loader or any of that stuff. Webpack has just given me JavaScript that I can put into the browser using regular script tags, and everything works. And again, Webpack is just one of those tools that slices and dices and does everything. So if I want Webpack to package up my CSS files and my HTML templates and fonts and all this other stuff, it'll put everything together, even if it has to base 64 encode things. So Webpack is cool, but I still do have some concerns over Webpack. I've seen a tendency in some applications where the application code becomes Webpackified. A good example would be, this is a piece of Angular 2 code, which everything appears normal here, but I want to point out this require statement. That require statement is not an Angular API. It's not a browser API. It's nothing that no one understands, but Webpack understands it. So when Webpack is processing this ECMAScript 2015 or TypeScript file, it can see that require and say, oh, you want to bring in an HTML template? Let me also build that into your JavaScript file so everything's put together. And that's nice because now my application can be served from perhaps just a single file. I don't have to send down templates and all this other stuff. But it always worries me when applications take a dependency on tools because in the world of JavaScript, how long do tools stick around? You know? Bower was a pretty hot tool like 3 years ago. How many people still use it? Well, I mean, there's a lot of people that still use it, but you know, how many of the cool kids still use it? I've also seen library and framework authors struggle with modules and dependencies. I mean, I'm building, let's say I want to build a framework on ECMAScript 2015. How do I publish that to other people to use? And do I need to build things ahead of time? Do I need to compile everything to the universal module definition that works with all sorts of different modules except ECMAScript 2015 modules? And what do I do about the polyfills that are required? Do I build them into my library or do I force you to load them in the browser? There's just all sorts of crazy things that go on with modules. And then the tooling in the space that you need, things like Webpack and the transpilers and all the npm this, and npm install that. To me, it's often like being on the ship that's on that ocean right there. There are some days that are very exciting. You're living on the edge. You're swirling around in the ocean, and everything is great. And it's just so exciting. And then there's days where you get like really close to that hole, and you just think the whole project's going down, and you're going to die. And you just want to get out of this world and get back to something sane, like C# or something, you know? Something that someone has thought through, perhaps excluding ASP.NET Core, but anyway. It's nuts. Things break all the time. So if you're going to embark on something that's going to use ECMAScript 2015, I hope I haven't scared you. I hope I have just prepared you. It will be the future, and if you do it today, yeah, maybe things are still a little bit early, so you're going to experience some pain. The biggest pain to me really is the tooling and setting up a build process, and all of that is extremely complicated and brittle and fragile. Anyway, I'm going to be sticking around for questions. I'll let you go since it's last session of the day. You probably want to get out of here and do something interesting. But if you want to contact me, that's my email address. I can send you the slides or whatever. That's me on Twitter. That's my website. That's where I do videos. And I think SSW is holding some Ask Me Anything session downstairs with me after this. So if you want to come down there, I can answer questions there. Thank you for coming out. Have a great conference.